Good morning everyone. Today I want to show how to simultaneously analyze Mann-Kendall trend and CV values or coefficient of variation in array software. So actually I'm analyzed such like in previous videos, but what I wanted to show today is very latest and very simple and time saving how to analyze Mann-Kendall and the coefficient of variation simultaneously. Still now, many researchers may analyze coefficient of variation in another format, and also Mann-Kendall trend is another format. But today, what I wanted to show is how to analyze this both of parameter simultaneously by R software. Follow me. So I wanted to open R software. I want to open R software. So look, I wanted to open R software. I'm already that we can start as a new. Here is new. So first, later I wanted to call the code of trends, code of trend analysis. Look, I have such like a code on my file directory is early. So here is the code for simultaneously analysis trend tests. Trend test. So here is first if you have already installed package of library in tdverse, trend, Kendall, and the ggplot, you can simply call to the library. Otherwise, if you haven't such like if you are install such like a package, first install those packages before going to analysis. So here is the data. The data format is here. By the way, ይሄ የዴታ ፎርማት ነው። ከፈለጋችሁ እኔም ሰጣችኋለሁ። ሶ በዚህ አይነት ዴታ ፎርማት አሬንጅ ካደረጋችሁ በኋላ ምን ፎልደር ውስጥ ነው ያለው? ለምሳሌ ዌር ኢዝ ማይ ፋይል ዌር ኢዝ ማይ ፋይል ዳይሬክተሪ ኢንሲ ዲ ላይ ነው ወይስ ደግሞ ሎካል ዲስክ ላይ ነው ወይስ ደግሞ ዴስክቶፕ ላይ ነው? ለምሳሌ እኔ ያስቀመጥኩት ማይ ፋይል ፎር ኤግዛምፕል ኤንዲ ከዲ ኤሪኖ ፒቲ ፋይል ዳይሬክተሪ ኮል አደርጋለሁ ወይ ደግሞ ኮፒ አድርጌ ወደዚህ አመጣለሁ ማለት ነው። So here you see here is the previous training, but today I wanted to show us new. Look, paste. When you are here is the slash to back. So if you wanted to back, so add one. Otherwise, go to slash to forward, such like. Okay, so here is my file. It is really no, here is not my file. My file is here. My file is here. Open. So you can arrange your file accordingly. Copy. For example, here is my file. Here is year, month, month, March, April, May, June, July, August, and annual. So if you are arranged accordingly, so I wanted to paste here. Now here is not monthly, my file name. Yes, so now my file name is draw trend and CV by R. Then what we call run. First run. Let we can run. Again run. So again also run. Let we can call the on read my data. My data is reading. Yeah. Again also convert it into the year. This is the basic setting, the maximum year and also the minimum year. And here is the month. You can call your month accordingly. Month from January to September. And here is the trend of a function. Here is the plot. If you have the ggplot, you can call into library and see the plots. The plot here, here is the plot. Here is the plot for annual And also here is the plot. The second is plot for Mann. Look, here is the plot for Mann, the plot for June, July, August, and the plot for months again also. So we can go to the trend function, and the CV coefficient of variation again. So you can call coefficient of variation or CV function. Here is the script you know, and it goes to the trend test. The trend test. I wanted to run trend of annual, trend of month, trend of June, July, August, and the trend for monthly. Trend for monthly. And it goes to coefficient of variation or CV values. Look, what about the CV value or coefficient of variation? If the CV value, especially rainfall, less than 20, we say it is low. If it is 20 up to 30, it is moderately. If it is greater than 30, you say high variation, or the area is, we say, dry or drought prone areas accordingly. Later we can combine. Look, combine in monthly order, annual, month, June, July, August, December, and I wanted to all result in bind. Look, very good. Again, so this is the final output, So here is the final output, and also the final output is what we need. Is here is the z values, sin slope, p value. What that means, the p value? Here is my p-value of the result. So you can compare the p-value with 0.05, 0.01, 0.001. For example, here is significantly uh, at 0.01 level of significant, we say. So it is highly significant impacted on the area. That is what means the area is highly drought prone areas, we say. If it goes to the significant, it shows the impact levels, You see here is less than 0.01. It is again, also the area is drawn prone areas. Here is like compared with 0.05. You see here is less than 0.05. And also you see here is the coefficient of variation low. Even if the coefficient of variation is tell us the bold significance on the level of agreement. You see, here is highly significant. So it is the CV value is very high. The result in the p-value shows again significant. So, and look again 0.62, which is greater than 0.05, but it is not significant, but the coefficient of variation is high. So accordingly, you can take this in table format and paste copy in your work, and also give to further discussion and elaboration. So where to save? I wanted to save in this. I wanted to save in my file directory, even, or you can copy paste from the above folder I already adjusted here, isn't it? Copy. Look, for example, copy, so paste, yes, paste here, you see, and also what is the final output is what called output for what? Research video. Let's assume that research video, let me say video, yeah, research video, for example. So I want to get this, so go to final, yes, add legend, save. Later I goes to my file directory here. Look, the output is here. Let we can open. You see here. Look at the p-value. What? At the p-value of 0.05, we get such like analysis. We get such like findings. Have you believed it? How we simultaneously analyze CV value and the Mann Kendall trend analysis simultaneously. So these are highly significant. Yes, the coefficient of variation also tell us the significance of these impacts. These impacts. So the area is, it shows the area is the drought prone area. You can copy and take into the Excel. For example, I wanted to show from my findings. For example, here is the Mann-Kendall trend analysis. You can take MK, science log, and give justification on these findings. For example, another one to show about the CV values. Look, CV values or coefficient of variation. Look, for example, the CV value of here. For example, okay, what about CV value here. Look, CV value. Yeah, what about the CV value? CV value is equal to, here is the standard deviation over mean times 100. Over mean times 100. Here is the formula, and also here is the trend analysis. So we can calculate simultaneously Mann-Kendall trend test and the CV values. CV values. CV values for any analysis or any analysis. It is very important and also time saving. Time saving. You can copy paste or you can open from your file directory and write in your thesis or research articles or manuscript. So thank you for your attention.